This is the K coefficient. Basically, it tells us how much attention people are paying to while looking at certain elements. In this case, that was a video. We collected this data from around 110 panelists from using mobile devices, smartphones, and we can see that from the results that this video gathers the most attention here at the end, around 30 seconds from the beginning. So today I would like to present to you my guest, Krzysztof Krejtz, who is one of the inventors of the K coefficient.
First of all, thank you, Adam, for this nice invitation and introduction, and thank you for having me here. I'm a psychologist, and at the University of SWPS, I do run the eye tracking research center, where we focus on different applications of the eye tracking research, mainly in the field of human-computer interaction, multimedia learning, and media accessibility.
So if you don't mind telling us a bit more, how did you, your team came up with an idea of what K is, why you developed it, and why the name K also? It is a mystery for us, so please could you elaborate a bit more what it is?
I do remember that quite well. It was a couple of years ago. We were doing the project about the multimedia learning, and especially learning from educational movies. And we were eye tracking kids, how they perceive the educational movies. And again, with the audio description, we were trying to manipulate the attention of these kids to trigger their attention and to spot the most important information, which were embedded in these movies. By the way, we found out that it is possible to guide the visual attention with auditory cues, and the kids with audio described movies learned much more and faster than kids watching the same movies without this additional sound embedded in the movies. But when we were analyzing the data, we found that quite often the fluctuations of the visual attention, and we noticed the changes between in time, changes of fixations, durations, and saccadic length, saccadic amplitude. That was not new, because we knew from the previous research that these two factors, they do change in time. And that was quite well known from DUCHOWSKI studies, but even from the studies century ago, from one of the first studies using eye tracking, Boswell's book on visual attention on art perception, that there is a dynamism in the visual attention which can be captured by saccadic amplitude and fixation duration changes in time. And what DUCHOWSKI and his team did in starting from their paper from 2005, that you can link the eye movements, and especially those two features of eye movements like fixation duration and saccadic amplitude, with two modes of visual attention and information processing, namely ambient and focal attention, which has quite nice roots and was quite well established in neuropsychology. What was missing in these works, and what was misleading and not really useful for us when we were analyzing the movies was that these two types of information processing and two types of attention, ambient and focal, they are not, in fact, binary. In fact, when you look at the process of attention, it's more likely that we have the continuous suite of shifting between ambient and focal attention when in a certain moment of time, the ambient attention is taking a lead, then for the next moment of time, giving the lead to focal attention. But the switch is not perfect. So you can be a bit more focal or a bit more ambient. And we were looking for any kind of a coefficient which will help us to analyze such a conceptualization of the ambient focal attention, and we couldn't find it. So, so we were in need for that to show the dynamics of attention during clips watching. So we took the DUCHOWSKI works and his team works, and we thought about how to calculate such a coefficient. And actually what helped us a lot was a deadline. The deadline of the paper submission to the conference where we wanted to show our results was approaching, and we had to quickly develop the coefficient to have the results and to have the information we want from the eye movements. So we came up with the idea of quite simple coefficient where we can, looking at the attention as a process and looking at the dynamics of attention, we thought that we can calculate such a coefficient of ambient focal attention for each pair of fixation and subsequent saccadic amplitude. We know that these two measures are on a very different scale, and it's quite hard to compare the raw data here because fixation duration is on the time scale in milliseconds usually, and saccadic amplitude is usually in visual degrees. So you cannot put it into one equation, but when you standardize these two measures, meaning when you convert them to Z-score, you can then put these Z-scores into one equation. So the first step was to convert the raw data, fixation durations and saccadic amplitudes into Z-score, and then looking subsequently on each fixation, subtract from the fixation duration the saccadic amplitude. That means that if you have the relatively, because these scores are always relative to the entire trial or entire sample, depending how you calculate it. If the Z-score is positive, it means that such a fixation duration is longer than the average, right? And the value of Z-score tells you how much in standard deviations, on standard deviation scale, it is above the average. When it is minus, it tells you how much in the standard deviation scale it is below average. The same applies to of course, to saccadic amplitude. So now when you subtract the saccadic amplitude from the previous fixation duration, then you know that in this certain moment of time, the person was rather in the focal or rather in the ambient mode. So when the saccadic amplitude is higher than average and fixation duration is below average, so relatively short, that means that this certain moment of time, the attention is ambient. Because people make big movements, big saccades with short pauses, short fixations. When fixations are long and saccades are short, that means that people are in this certain moment have stopped exploring the visual field and they are more in the focal mode of attention. What is nice here is that such a simple subtraction gives you also not only the information whether the person is in the focal or ambient mode, but it gives you also the information how much on the focal mode the person is in a certain moment, or how much in the ambient mode the person is right now. So that was actually what we were aiming for. So having such a single number for each fixation and subsequent saccade, for being able to annotate them as ambient or focal, and also how much on this continuum, because we think about it as a continuum, which makes much more sense also from the neurological point of view than just a binary model, how much on these two modes the attention actually is. So having this, now you can nicely plot the dynamics of attention, and you can nicely see that people usually start from being ambient and switch in a time to more focal mode until the time when they got bored or they found what they are looking at, the scene they are looking at, and they go down to be more ambient again. And that's actually such a nice fluctuation between ambient and focal, and slow switching between these two modes. We were, or tonic phases between these two modes, we observed in our data. So then we could draw the conclusions for these certain projects we were running, how the attention looks like, and could answer the question, why guiding the attention of kids during multimedia learning can benefit in accuracy of this learning. That can benefit because that's what we saw. They stay longer in the focal mode, meaning that their information processing was deeper, and they gave themselves better chance to remember what they were learning at the time. So that was the origin of this coefficient. Super. And it was it's quite trivial. I think the deadline plays a crucial role here. So from that moment of time,
deadlines are deadlines. Good in this. So deadlines are the motor,
deadlines are
the fuel for development.
Oh, really? At first, we were describing this coefficient in a more descriptive way. When you look at the first papers, this is called ambient focal coefficient or ambient focal indicator, quite differently. But then, after a couple of projects, our collaborator Andrew DUCHOWSKI, our great, some people say the great DUCHOWSKI, he said, well, you're using this coefficient, it's quite good, but the coefficients usually are annotated with kind of a letter for ease of using this in the papers. And actually, that was his idea, and he suggested to name it a K coefficient, we did not discuss it. He actually wrote in his part of the paper we were writing at the time. He used this name K, and he said that's a good name. We should keep it. I said okay. There is no K coefficient in eye tracking research, especially none of these second order coefficients, which are around in the eye tracking community, is not called K. So it stayed there from that moment that it is K coefficient. So that
Super.
was the
Thanks for
so deadline again for the idea, calculation, and for name.
Super. Thanks for the answer. So who was there in the team that was working, that invented it, and that kind of like described it in the paper? I read the paper, the first one you mentioned, so the ambient versus focal attention. So it was. I know that you were leading the paper. Who else was there involved? Maybe that would be nice to mention.
Right. That was my name, and my best collaborator Iza Krejtz, and DUCHOWSKI I've mentioned already. And this first project was also AGNIESZKA SZARKOWSKA. She was responsible for audio description and of this idea of using audio description for sighted children to help them in learning. So these this personal was a key personal, basically.
Okay, thank you. Thank you all. I have to say that we recently did several tests in our platform, RealEye.io, with the K coefficient, and we actually observed several different behaviors from our participants. That, for instance, whenever they recognize something, then the attention goes more focal than ambient. So, for instance, we are showing a blurry image together with our Latin America friends. We're showing like a blurry image, and then it comes to it's getting sharper in time. And then whenever they recognize the brand or the product, then their attention gets more focal than ambient. So, yeah, it works. Does it work for everyone? Is it like so unique that, or there are some individuals who have different kind of like setup when it comes to eye movements and data processing, or it's rather pretty generic?
First of all, I'm not surprised by the results you found. That's the first time I hear about it. But we found out also that at the moment of decision in the situation of decision making, just in the moment before taking the decision, the attention gets usually quite high on focal side. We found it for deciding on emotions people read from other people's faces, and more abstract decisions as well, and classical decision tests. So before decisions, usually the attention gets more focal. Also, we found it that this effect stays in the visual search task. So just in the moment before finding or at the moment of finding the target you are looking for, the attention gets more focal. What is quite universal and robust is the general dynamics of looking at the scene. So whatever scene you are showing to the participant, to the person, at first, the person attention is ambient. That stage can last for a second or two, or even shorter sometimes, and then it is switching slowly to being more focal. Such a pattern of attention dynamics is actually not our discovery. That is quite universal, and Velichkovsky, Panache, Jews, they all were writing about, they found such pattern in very different using very different stimuli, from emotional pictures to products, old art reproductions, and so on. We can confirm that such a general pattern is very robust and quite universal. Also, when people watch films, whenever you have a scene cut, the attention just after the cut, the attention gets ambient. So that's quite natural for people to start looking at the new
kind of
image
like looking for the next anchor.
Yes, to have a quick glimpse at the whole image, at the whole scene, to see what's there, and then process quite simple perceptual features of the scene. And only when something is more interesting or gets more interesting, you tend to look closer at this spot.
Okay.
So, fixations are getting shorter, and saccades are getting shorter and fixations longer, meaning you put more effort, cognitive effort, to process these information. So such a general pattern is quite universal. But what is really nice, that in the different conditions, you can find that these patterns can be slightly different. In some conditions, people can get into focal mode quicker than in the other conditions, or they can disengage from the focal mode quicker than in the other conditions. What's even nicer, that you can manipulate with these dynamics, and it can has consequences for information processing.
So, for example, instance, the audio description for kids caused that they were processing more focal than ambient. That was kind of like
exactly. So when you manipulate with these dynamics, and when you somehow trigger people or help them to be more focal, they will process more. In a learning situation, it's super useful, and actually what we very often aim for. But you have to remember that you cannot stay focal for too long, and that really depends on personal differences, on individual differences, depending on your working memory capacity or other cognitive functions. You can stay longer or shorter in the focal mode to not exceed the limits of your working memory.
Okay. One question here. So basically, what is the difference between the cognitive demand and the K coefficient in time? Is it something that is it should go very similar way on the graph, or these are kind of like, are they connected?
They can be related, but these are completely different concepts. Because with the cognitive load, you refer to the amount of information you can process without exceeding your limits, cognitive limits. But with the K, you rather capture the attention and the process which is behind the attention. So there can be the correlation, namely, more focal mode can yield more cognitive load. So going from this correlation, you can think of the ambient mode as a kind of a pauses in for your cognitive system not to get overheated. But these concepts are different.
Okay. Great. So one last question. are there any future work planned to develop K even further, or this is kind of like closed box that is already named? It works. We named it, so it's kind of like ready to use. Or are there any is there any future to K development?
Yep. As I said, the K coefficient is so-called the second order eye tracking metric or indicator or coefficient. But we think of adding more information into this, like, for example, information about the cognitive load, which can be depicted from pupil size or pupil oscillations, or from microsaccades. And as our research shows, you can really find those moments in time where you are extremely focal. And the other indicators shows that these situations are extremely cognitively demanding for you. So we can, and I think we will, aim for the extended version of K, having the third order coefficient, which will include even more information to be able to better understand the information which comes from the eye movements. And the other path we are approaching is to have the K coefficient calculated in real time for certain usage in the computer-human interaction. And as we all know, the real time is a big issue right now for systems to react on time, momentary, at the moments where it is needed. For example, when kids are learning, that's good to find those times when they are focal, so you can provide more key information at these moments. The system can do it, or the teacher can do it, or to find moments when they are overloaded, and then you have to give them the break.
Yeah, makes sense.
I'm talking a lot about the education because it's quite natural to apply it for education, but you can also apply it for quite easily for marketing. And if you present the TV ad, for example, and you see that in the most for the most viewing time, your customers are staying ambient, or especially in the moments where you present the branding, they look at something else, or they cannot focus. That means that despite the fact where they are looking, you can find yourself in a situation that this ad will really can be remembered, but the key information can be lost, or the key message can be lost by your potential customers.
Yeah, that sounds pretty powerful, definitely. Okay, Krzysztof, thanks for this short session. I hope that we are going to spread the word with the information about K, about the possible usage, and maybe someone will kind of like contact to maybe help with the development, or maybe someone is working on similar things. So, you know, it's always good to spread the word out to the world about things like this. So thanks again. And
thank you, Adam, for having me here.
Thanks for joining me.